Welcome to the studio of Simplified EGD, your go-to learning space for mastering engineering graphics and design.
Next method to construct ellipse is we are going to see a rectangle or oblong method. Here it is given that major axis and minor axis of ellipse are 120 mm and 70 mm. Draw tangent and normal to the curve. So as we know that an ellipse has major axis and minor axis are at 90 degree. So first of all construct major axis of 120 mm and at 90 degree from the midpoint. Construct minor axis of 70 mm, 35 mm above, 35 mm below. Give the name A, B, C, D. Give the dimensions. Major axis is 120 mm and minor axis is 70 mm. Now prepare a rectangle from this ABCD point After constructing this rectangle, we will divide these three lines into equal parts. Let's say 3 equal parts. So divide this line into 3 equal parts. We will draw a line which is less than the 90 degree. Then take a small measurement. We want to divide this into 4 equal parts. So draw 4 equal arcs. First arc, from the first draw second arc, from second draw third, and from third draw fourth arc. Connect the end arcs, then draw parallel lines from each arc. Now we can also divide this line by the same method, or we can project the divisions from here to here by means of ruler scale. As well as we can also follow the method like measure this distance. Okay, put on a transfer the measurement. Okay, then transfer the same measurement from here to here. Now again to divide this line, we will divide this line first, then transfer the dimension from here to here. Okay, draw a line which is less than 90 degree give 4 measurement, draw 4 measurement, first arc, second, third and fourth. Connect end arcs. Draw parallel line. So we have divided this line into 4 equal arcs. Now transfer the dimension from here to major axis. Take a measurement, transfer the dimensions, and now give the numbering. Just take care, here A point is the same point for all these 3 dimensions. So give numbering 0, 1, 2, 3, 0, 1, 2, 3, 0, 1, 2, 3. Similarly on this side, 0, 1, 2, 3, 0, 1, 2, 3, 0, 1, 2, 3. Now connect this C point with this 1, 2, 3 and this 1, 2, 3. C point 1, 2, 3. Similarly from this side, similarly connect this D point, this 1, 2, 3 and this 1, 2, 3. Now from D, draw a line which is passing through these points from 3 up to 3 number line. From D, line is passing through point number 2 up to 2 number line. From 1 up to 1 number line. So it will look like this. Similarly on this side, D passing through 3 up to 3 number line. From D passing through point number 2 up to 2 number line. From D passing through 1 up to 1 number line. Similarly from C point, we will follow the same method, passing through 3 up to 3 number line, passing through 2 up to 2 number line, and passing through 1 up to 1 number line. Similarly on this side, passing through 3 to 3 number line. Here you have to remember the orders of numbering and orders of lines. Now you have received multiple numbers. This is your first number, P0, P1, P2, P3, P4, P5, P6, P7, P8, P9, P10, P11, P12, P13, P14, P15 and P16. Now draw a smooth curve from that pass through each points. So your ellipse is completed. Now to draw tangent and normal, we will follow the same method. First of all, indicate focus point. So we will measure A to O means half of the major axis, then put on one of the point of minor axis. We will draw arc on ellipse major axis, that will give us focus F1 and F2 here. Okay, now take any point, let's say M point is here, connect this M point with F1 and F2. Now bisect the angle covered at point M. Now pass the line which is passing through intersection of arcs and point M, that will give you N dash normal, and perpendicular line to that normal will give you tangent TT dash. Okay. Next method to draw ellipse is a parallelogram method. It is given that the conjugate diameter of the curve are 120 mm and 70 mm. Here the word is conjugate diameters, not a major and minor diameter. Okay, that we need to identify. Draw the curve, name the curve, and draw tangent and normal to the curve. Conjugate diameter, initially we are considering as a major and minor diameter, and one term is missing here. It is also given that conjugate diameters are at 70 degree with each other, means these are not at a right angle. Okay, so first of all we will plot 120 mm major conjugate diameter. Now from the midpoint 6 mm we will measure 72 degree. (70, 71, 72). Okay. Now we will plot a line having a minor conjugate diameter of 70, means 35 on upper side, 35 on lower side. This point and this point. Now with the help of roller scale we will prepare a parallelogram. This angle is 72 degree. This method is same as rectangle method, but the axis is just at 72 degree. Remaining portion will be same. Okay, now we will divide these three lines and these three lines into equal parts. Give numbering A, B, C, D. Divide this line into, let's say, 3 equal parts. So we may take a smaller measurement on rounder, draw 3 arcs to divide this line into 3 equal parts. Similarly, we will divide this line to 3 equal parts. Take any measurement, random measurement. 1, 2, 3. Connect the endpoints. Draw parallel line from each points. Same for this line. Now transfer the dimensions, transfer the divisions. From this point to here, from this point to here. Now from this point to here and this point to here. Similarly, we can draw a line, draw arcs and divide this line also, as well as we can transfer the dimensions from this, because all the lengths of this parallelogram are equal. Same to same from this portion to this portion. Now give numbering 0, 1, 2, 0, 1, 2, 0, 1, 2, 0, 1, 2, 1, 2, 1, 2. Now connect this C point with this 1, 2 and this 1, 2. Same for D point. Now pass the line from D, that is passing through 2 number up to 2 number line. Here it is 2 number. From D point, draw line passing through point number 1 up to 1 number line. D 2 to 2 number line. From D 1, from the 1 to 1 number line. Similarly from C point, draw from 1 number up to 1 number line. From C point 2 up to 2 number line. Now give the numbering to each point. This is your P0, this 0 point is your P0, then P1, P2, P3, P4, P5, P6, P7, P8, P9, P10, P11 and again P12. Now draw a smooth curve which is passing through these points. In each curve, maybe you have noted that for these endpoints, your curve will not go outside of these endpoints A and B, but when it is given conjugate diameters, your curve will go outside of this point. Okay, so its major axis and minor axis are different than this. So now we are going to identify that your curve is generated. So give the name, give the dimensions, is incline measurement is of 70 mm. The angle is indicated here. Now this measurement is 120 mm. Now to identify the major axis, give numbering O. Take a dimension from O to C and draw a arc more than a half circle which will cut this circle at point number, let's say C dash, or maybe let's say D. Here it is D, so D dash. Connect this D point with C. Draw parallel line from O point. This end point of curve, this will give you C double dash, D double dash minor diameter, and perpendicular line to that from O point. This will give you major diameter A double dash, B double dash. Now for tangent and normal, we will follow the same for major diameter. Take a measurement from A double dash to O, put your rounder on C double dash, draw arc on A double dash, B double dash, your major diameter line F1, and this is your arc, so F2. Take any point M on the curve, connect end point with both focus. Now M has covered one angle. Now bisect this angle at M. Draw arc from that arc. Draw another arc from first point. Next arc from another point. M point and this intersection of arc. Draw a line that will give you N and dash normal. And perpendicular line to that, you can draw your perpendicular line like this. Align this line with 90 degree. Make here M point exit center. Mark at 180 or 00. From both point, you can draw a line that will pass through the point M. This will give you T dash, tangent to the curve. So this is your parallelogram method.